flipping through all the screens, making sure I have all the things open, and I now have all the things open except for Audition. So I'm sorry that you have a faulty system in your brand new house. That is the most ridiculous problem.
So we bought a nice bidet toilet 2 years ago, and the lid on it is broken. And so you look, before the lid would nicely close, and now the lid just slams shut if you aren't careful about it, and it's starting to like smash and sort of break the back of the lid.
Oh, no.
And so we're like, let's get a replacement. It's like clearly there's a little break that fits through where the lid comes down.
Yeah.
And we've contacted the company, and we don't make that toilet anymore, and we don't sell replacement parts for it. So we have a fancy toilet that now there's no way to repair it.
So I feel like you should be able to get a third-party lid that serves that purpose.
It's super custom for the toilet, which is like obviously duh. like if you're not going to follow the standard toilet lid shape, then it's a bidet, and the toilet is heated, the seat is heated, and has all kinds of technology rolling through it. So we should have gone for a proper Japanese toilet in the first place. I would still 100% recommend about getting a bidet. They're the greatest thing ever.
I prefer the more Scandinavian handheld butt blasters. I'm sure they have a fancier name, but this is what we call them around here.
Handheld?
Yeah. So I encountered these when I was in Finland, where there's this thing that looks like the spray nozzle off of your kitchen sink that you have instead, and so you can just spray whatever needs to be sprayed and direct the force as needed.
Right.
And it's useful for more than just the purposes of a bidet, because as a fish tank owner, it allows me to also like fill buckets of water and
right.
So
that's
the
funny.
Scandinavians, I approve of how they did this. And with our super old house, it was a whole lot easier to retrofit to add butt blasters than to add bidets.
Yeah, the problem is you've got to be able to plug in your toilet.
Right.
To get the warm water.
Yeah.
And to have the heated seat and have the heated blow dryer on your butt.
We don't have any of that fancy stuff. We just have a spray of water.
Yeah, it's awesome. Yeah, highly recommend it. And so we are, like, it is existential for us. Right. We're like, oh my God, the toilet doesn't work right. What are we going to do? They've got to fix it, right? So now, because it's one part, like I can see the part that's kind of broken out a bit, and I just need the specs on that part. We'll get it 3D printed. We'll swap it in if they're not going to produce it. But I want them to tell me to my face that they refuse to help us repair their toilet, because it was only 2 years ago.
Yeah, so there's no sense in having that kind of planned obsolescence for toilets.
Yeah, totally. All right. I guess we should do our job.
Yeah, hold on. I found one place I forgot to update. Okay, I now think I actually have everything updated. Are we good? I think... Yes. All right.
Okay.
All right.
Here we go.
I am pressing record there. I am pressing... Wait, I have to check. Ugh. I rebooted my computer, so all the audio settings changed.
There's your problem.
Never reboot. Don't do it.
Yeah.
Okay.
Yeah. Look, I find the Windows PCs recovers a little better than the Mac. The Mac, I figured out how to make the Mac to force it into going to the right audio settings after every reboot, but by default it wants to go back to its stupid speaker on the outside of the Mac Mini.
Yeah, my Windows system, it does not recover well from reboots either. So.
No, none of them do. You always have to be extremely distrustful. I've lost whole recordings because I was recording on the wrong device because it didn't recover nicely.
We are now. I figured out.
You're
all
now
my
recording?
settings. Yes.
Okay, here we go. Astronomy Cast, episode 744, Lunar Time. Welcome to Astronomy Cast, our weekly... I'll just do the whole thing. Astronomy Cast, episode 744, Lunar Time. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand, this one more time. Astronomy Cast, episode 744, Lunar Time. Welcome to Astronomy Cast, your weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist. I'm just going to keep going. All right. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing mostly well. I rebooted my computer and it lost its brain, which caused me to lose my brain. But I think all brains have now been gathered up.
I think the fact that we have been wrestling with audio, software, hardware, codecs, gain, normalization, leveling for the entire length of time of Astronomy Cast
18 years
is hilarious. and I don't mean that in the it's been funny. I mean it's the enraging. We have why is this a problem? Why is this happening? Why, after 18 years, can you not have a microphone connected to a computer that the sound goes into the microphone and is recorded by the computer and it's fine? Is that too much to ask?
Yes.
It is. So this is what we get. And this is what you get, which is us having hardware, software, audio devices betray us. And you, the listener.
The thing that gets me at the most stupid level is they have now added rainbow LEDs to every single piece of technology. And they can get all those rainbow LEDs to sync with this, that, and the other thing, to display brand colors, to display whatever the heck you want. Light, in terms of making things look rainbow of your choice, they got it. Lighting of green screens, hard. Audio is impossible.
Impossible. Can't be done. Wait, anyone who's going to try to do audio, you're out of your mind. It is just, there's no way that anyone can record audio from a microphone onto a computer and have that be saved. That's how it's rocket science. All right. What time is it? Okay, fine. What time is it on the moon? The moon orbits the Earth, so it doesn't fall into a specific time zone. Also, there's lower gravity on the surface of the moon, which changes the rate the clocks tick. Well, it's time to introduce Lunar Time. And we will talk about it in a second, but it's time for a break. And we're back. All right, so when did the international space exploration community realize that there is a problem with thinking about time on the moon?
So there's always been this, we need to worry about this concern going on. Even during the Apollo missions, they had insane amounts of updating of the clocks to make sure they could figure out how fast they were going in feet per second, to figure out where they were, to figure out all sorts of different things that you don't realize require you to know when you are. And since we didn't stay on the moon, it didn't stay a problem, and it kind of fell by the wayside because there are a lot of problems in space science that need solutions, and that one could just wait. But in the early 2020s, as it became clear that a new moon race was on, as it became clear we were and are going back, some of us, someday,
somewhere, some combination.
It started with ESA being like, okay, we need to start defining this. We need to start figuring this out. And so ESA started putting together working groups in 2023, and not to be outdone. In April of 2024, the White House put out a memo that is no longer available on the internet. Gripe of the day.
It's really helpful for doing research, background research on this. Fine, we'll just go with what the Europeans say.
There are so many points of information that no longer can be found. But anyways, moving on to discuss the reality of the situation. So it was realized we need to define this, and the White House in April of 2024 said, NASA, you do you, coordinate with whomever you need to coordinate with, and by 2026, we want a lunar coordinated time. This is because everything gets abbreviated stupid. It's called Coordinated Lunar Time, and it is abbreviated LTC, which is consistent with Coordinated Universal Time, which is UTC.
So you're getting a lot of noise from your hair swiping your microphone.
Okay, I need to redo that rant, don't I?
Nope, but just quit it. Put your hair behind you. There you go.
All right.
Yeah.
Sorry, everyone.
Okay.
Long hair problems.
Oh, Crimea River. Okay, so we've got lunar coordinated time. And what is the proposal for lunar coordinated time? What will it be?
Well, and this is where it gets, what is the problem that we have to solve is the starting point. So, for instance, why is it that when astronauts go to the moon, they can't just use Houston time, which is pretty much what the Apollo astronauts did? Why can't we, in general, just sync our clocks with the clocks on Earth and move on with life? And the problem's relativity. So in the initial, what does this need to entail? They identified it has to be have traceability back to UTC. It has to have accuracy for navigation and science, and it has to be scalable beyond the Earth-Moon. And all of this means we need to define all the parts of the equations that cause time to speed up and slow down based on the size of the gravity well you're in and how fast you're moving.
Right.
And luckily, the moon's motion is not the dominant factor. We can figure it out. It is getting thrown into the calculations. It's actually the difference in the mass between the moon and the Earth that creates the biggest problems that we have to be able to correct for. The Earth has a much bigger mass, which means that our aging is slower compared to people who are in orbit around us who are aging faster. Always think of the I just forgot the name of the movie.
Interstellar?
Yeah, always think of Interstellar when you're trying to remember who
totally.
ages. Yep. This is
that's true. That's for me. That's first principles is Interstellar.
Yes.
Think back in Interstellar. He spent a day near a supermassive black hole, and when he came away from the supermassive black hole, his daughter had experienced 40 years.
Yeah.
And so, that clocks run more slowly near to higher gravity, gravitational wells.
And slower clocks means you age less. Faster clocks mean you age more. Just for people who need to get all of that straight in their head, which includes people like me.
Right. But the balance that you're mentioning, though, is it's not just the fact that you are near a gravitational well. If you are farther away from the gravitational well, then the clocks are going to run more quickly for you. But then also there is the speed of your spacecraft relative to the person who is not. And so you've got a spacecraft that is going, and then it's flipped in reverse.
Which the ISS has. So with the International Space Station, they're going round and round at a zippy pace. And because they're going at a zippy pace, they are aging slower than the people on the surface of the planet. Here's where you think of Ender's Game.
Right.
I apparently do everything by movie reference.
No, I think that's perfectly appropriate. And then, in fact, there is a perfect balance point where the people who are in space, and I forget the altitude, but there's a place where you will be compared to a person on Earth, you're experiencing less gravity, so your clock is clicking more quickly, but also you are moving faster, and so your clock is clicking more slowly, and there is this perfect spot that you could be orbiting around the Earth, and you wouldn't experience any time drift with those two factors. But the point that I think, back to what you're saying, right, that when you're on the moon is going around the Earth, that when you're orbiting around the moon, you are going at a certain velocity relative to the Earth. When you're at a lunar halo orbit, you're going a certain speed. When you're down on the surface of the planet, you're experiencing different amounts of gravity, and that the clocks are going to tick at a different time compared to a person on the surface of the Earth for every single one of those conditions.
Yeah. And this is where the White House in April of 2024 gave NASA until 2026 to figure this out. And
all right, you know what? I want to take a break.
Okay.
Before we figure out, this is a cliffhanger.
Yeah.
They were tasked to figure this out, and what they discovered was, and we'll be back in a second. And we're back. What did they figure out?
They figured out, they being the National Institutes, I forgot what the S and the T are for, in National Institute of Standards and Technology, NIST, the National Institutes for Standards and Technology, figured out that it is, when you do all the equations and you consider the orbital motion of the Earth, the orbital motion of the moon, it is the mass difference between the moon and the Earth that dominates the difference in the equations of time between the two. And
not the speed.
Not the speed. It is not the speed that is the dominant factor. And because of this, there is, and here I'm just going to read from a paper that came out in August of 2024 from NIST. The citations authors are Neil Ashby and Bunjanath Patla. We estimate the rate of clocks on the moon using a locally freely falling reference frame coincident with the center of mass of the Earth-Moon system. A clock near the moon's solenoid ticks faster than one near the Earth's geoid, accumulating an extra 56.02 microseconds a day, which is a very, very fancy way of saying that at the surface of the moon compared to the surface of the Earth, that clock is ticking faster. You are aging faster on the moon, and it's a small amount, but it's an amount that's going to add up. And it's an amount that if you don't take it into account, once we start trying to develop a global positioning system for the moon, we won't be able to do it. And the other thing is that as we start doing things like building telescopes on the moon and trying to coordinate data between lunar observations and Earth-based observations, if we don't take into account this difference of 56.02 microseconds a day, our ability to align those data sets won't be there. So things that are affected if you don't take this into account. Obviously pulsar timing, that's super simple. Where things are is going to drift over time if you don't take it into account and you try using the exact same global positioning system equations that we use for the equations are the same. If you start using the same values that we use for our Earth system, it's not going to work. You're going to have to update the chips that go in your phone and run the calculations to have the right constants. One of the most amazing things that's going to be totally different if you don't take this into account is our ability to do interferometry at radio wavelengths. Because right now, we can have different radio observatories all over the world tied to their atomic clocks, taking observations with those timestamps inside the observations. And using amazing computer systems, we can shift the data around to align the incoming radio waves to create a radio dish that's the size of the Earth. Now, when the radio waves are coming into the moon, we have to account for the difference in distance to the lunar dish and the Earth dish. That's one thing that has to do in the process of aligning the data. But then we also have to either stretch or compress, and in this case, it turns out if time is going faster, you have to stretch the data out to get the time that's passing to be the same for the data collected on the moon and the data collected on the Earth. And that's just wild to me to think about. Time is going to affect things at that level.
Your hair again.
Okay, I'm apparently going to use a bull clip to hold back my hair.
Perfect.
Rich, feel free to leave this in so our audience knows what chaos is occurring when they get the audio file. I am very sorry, everyone. I am going to have some housework done next week to seal the walls of my studio, and so I haven't set my good mic back up after getting a computer.
Right.
Because I'm just going to have to move everything anyways. So
this
is a high-quality mic. It's just subject to long hair.
All right, we're going to continue this conversation, but it is time for another break. And we're back. Right, so it's kind of fascinating to think, like, the nitty-gritty details. People are like, oh, I want us to be living on Mars. We want to have a future solar system spanning civilization. But you can imagine somebody, now detail has to show up and sort of join the conversation. And can you imagine taking that concept to the next level where, like, oh, okay, what does it mean to be out at the L2 Lagrange point? What does it mean to be on Mars, on the surface of Mars, in orbit around Mars, on Phobos? What time does Parker Solar Probe experience compared to the time that is experienced by us here on Earth? And that a future solar system spanning civilization, especially one that's attempting to conduct science operations, trying to synchronize global positioning systems and communication systems to manage the time delays, is going to just have a headache of the nth degree. It's mind-bending. And yet you can see, if you don't account for that time dilation, then you are not going to be able to align the measurements made by a interferometer that's operating between the Earth and the Moon. You are not going to have an accurate timekeeping of when events happened so that you can make sure that the packets are arranged in the right way to put together a communication system. Like, all of these are actually going to be a big enough problem that the European Space Agency is assigning a group, NASA is assigning a group, and they're going to come together with some future global standards that then everybody, including the Chinese, probably will have to work with. It's crazy. It's kind of humbling.
It's not linear. I mean, this is the crazy thing. Because things are on elliptical orbits, the offset in time varies with time. So you have to basically define, this is the moment at which clocks are synced. And now, to figure out when this place is compared to when this place is, you have to take into account the overall offset due to mass, which is a standard. You have to, we assume the mass of the moon will remain constant. It's a good idea. But then you also have to take into account that, yes, there is a subtle difference due to orbital speed that can mostly be ignored, but not completely be ignored. And the orbit's an ellipse, so the difference in the rate of time passage varies as a function of where you are in your orbit and the rate you're going in your orbit. And this is something that you have to take into account for every world, for every different mass object. And you have to layer on I'm on Phobos, which means I'm in motion due to going around Mars, but I'm also in motion due to overall motion going around the sun. And then you have to take into account the fact that when you're looking at the signals, the time that it takes each successive wave getting to you is going to be different. So there's a Doppler shifting of the signal. Now, that doesn't affect the rate of time, that affects the rate of incoming information. But all of these things have to be taken into account as we send and receive information about the universe around us and about our world and the worlds we're trying to communicate with. In trying to define time, poor Aspie and Patla, in their paper from NIST, they set out to look at not just how time passes on the moon, but they also considered the various Earth-Moon Lagrange points as places we also need to take into consideration, because this is where we're looking to put things like the Lunar Gateway. This is where we're looking to put communication satellites to communicate with the far side of the moon. All of these different places have different passages of time.
And it's interesting, if you go back to that definition that you provided, it's that you were assuming a soliton that is in orbit around the moon, or a soliton. And that's interesting, because that's very similar to the way the astronomical unit is described. Like the astronomical unit, the rough version is it's the average distance from the sun to the Earth.
Yeah.
But in fact, that isn't accurate, because the Earth is pulling on the sun, and that's causing a wobble on the sun's position. And so the distance from the sun to the Earth changes, not only because the Earth is following an elliptical path around the sun, but also the fact that the sun is wobbling at tens of centimeters per second forward and backward, thanks to the gravitational pull of the Earth. That is, they're both orbiting around the barycenter.
And Jupiter's the dominant
of course
factor.
For sure. And so when you measure an astronomical unit, you are imagining a soliton. If you're measuring, if you're going to follow NIST or whatever, it's a soliton orbiting the sun, because that has no mass, and that is theoretically not pulling back and forth on the sun. And so the reality is inaccurate by a certain wide margin, not just because of the movement of the Earth, but also the movement the Earth causes to the sun. Yeah. And so when you're considering this, they very specifically said we're going to consider a soliton, because if we consider something that has mass, then that is going to affect the positions of things and just make things even more complicated. And so it's a lot of the times we have these conversations on Astronomy Cast about things that are theoretically possible but practically not relevant. Like, could we look backwards in time by looking at the light that was going around a black hole to see a time in the past? Yeah, theoretically, photons are making the journey from the Earth out to a black hole. They're coming around the backside of the black hole, and they're making their way back to us, theoretically. But practically, no. But in this case, slices of time that are so small are actually practical.
Yeah.
They're having a practical implication to the way we will conduct our exploration, to the point that, people could die if you get this time wrong.
Yeah.
And so we have to take into account, and yet it is mind-bendingly complicated. I don't think anybody will ever go, oh yeah, we lost 60 microseconds today.
Well, and then you have to consider the fact that we have stuff like leap seconds here on the surface of the Earth.
Yeah.
And so when Earth leaps seconds, what do you do with the rest of the solar system's time? Because that leap second is aligning us with our world's orbit and rotation relative to the sun and stars. Other worlds aren't going to have those exact same needs for realignment. And there's stupid stuff that changes on the surface of our planet, like when China put together their, 5 Gorges Dam?
Three Gorges Dam.
Three Gorges Dam. That changed the rotation rate of our planet because the moment of inertia changed.
Yeah.
And we have to periodically upgrade.
Yeah. The rotation of the Earth is slowing down because the moon is moving away from us. And I forget the exact number. I've just noticed this, and I'm sort of incorporating it, but it's on the order of tens of microseconds per day per century. is being caused by this slow, the Earth's rate of turning is slowing down in a rate that is measurable. And I think you're exactly right. When we deal with leap seconds, or it's this, it was fine, and now it's not fine. Now we have to go back a whole second.
Right.
And does everybody across the solar system, or do we switch to there is no such thing as leap seconds? There's no such thing as years anymore. You just accurately measure. Yeah, star dates. Yeah, exactly. Is this star dates?
I think it starts to become that. We have Julian dates that we use in astronomy that go back to a set time and get calculated forward, and it gets messy. So what
is the I don't know the way it works in Star Trek.
I don't know.
Where does the star date originate?
I don't know. And I wonder, do you know this? I'm realizing, so with Earth we have one moon that creates enough havoc for us, and because it is moving away from us, because its orbital rate around the Earth is longer than the length of our day, it moves out. Now, Mars has two moons, one that has an orbital period shorter than its day and one that has an orbital period longer than its day. Which one dominates? I
think Phobos is dominating, so it's speeding up its rotation until Phobos is destroyed.
Okay.
And then it'll be Deimos that dominates and slows it back down again.
Yeah, so not our problem, at least.
No. Future Mars problem.
Yeah.
But it still just kind of blows my mind that our technology is so accurate. We deal with these wavelengths that are nanometers across. Our technology is depending on this kind of stuff, and we're getting to this place in our sort of world, our advancement, that these are issues that we have to take into consideration, or things break. Right?
Yeah.
Ships go off course if you don't take into account relativistic issues. You don't take just time dilation into account for the GPS satellite systems. And now ships will go off track when they're trying to go to the moon because we're not getting the time right.
Yeah.
Or we will. Yeah. And so you're going to have a clock on board that is adjusting based on that. And then you think about, say, like the I Am Legion, We're Legion, I Am Bob series, where he has communications between different versions of Bob, and they are moving at different rates relative to the speed of light, and they have to experience different amounts of time dilation as they try to talk to each other. And then they have ways of accounting for that, where one version will just wait around or do other things while he's waiting for the frames to come in for another version of himself. And I guess it's like, but nice problems to have, that we're so advanced that we now have to take into account relativistic effects when we attempt to communicate. I think it's great.
And this is where ultimately pulsars will form one of our most important coordinate systems. We're going to rely on how time passes relative to those objects. And this is one of those things that the Foundation series, which I need to go back and rewatch because I haven't watched the second season yet, the Foundation series really hits on this, looking at how time passes as you travel and how you measure your place.
Well, I think we should cover for pulsar timing as a future episode, and talk both about the pulsar timing network as a gravitational. We talked about gravitational waves, but also as a potential way for timing. There's some interesting work on that. So that's a future show.
Could be next week.
Oh, maybe. Sure. Thanks, Pamela.
Thank you, Fraser. And thank you so much to our patrons who allow us to have a team that usually cleans up what we can do, although I don't think Rich is going to be able to correct what my hair did to this episode's audio. I am so sorry, everyone. This week in particular, we would like to thank Alan Gross, Alex Cohen, Andrew Stevenson, Bebop Apocalypse, Brett Mormon, Cami Rassian, Daniel Loosely, Danny McGlitchy, David Gates, Disastrina, Dr. Woe, Dr. Jeff Collins, Ed, Elliot Walker, Father Prax, Frank Stewart, G. Caleb Sexton, Gerhard Schweitzer, Gordon Dewis, Gregory Singleton, Jarvis Earl, Jeff Hunamorder, Jeff Wilson, John Drake, Keith Murray, Kellyanne and David Parker, Kimberly Reich, Christian Golding, Laura Kettleson, Lee Harborn, Mark Phillips, Matthew Horseman, Matthias Hayden, Michael Perchada, Mike Dog, Nyla, Noah Albertson, Red Bar is watching, Shersum, Simeon Torfason, Ziggy Kemmler, Stephen Veit, The Big Squish Squash, The Lonely Sand Person, Travis C. Porco, Adam Anise Brown, Adam Moore, Arctic Fox, Benjamin Mueller, Bob Zatsky, Buzz Parsec. I went into next week's names. Some of you will get thanked twice. Thank you all so much for joining us and making what we do possible.
Thanks, everyone, and we will see you next week.
Bye-bye. And then they saved.
And then they saved. Uh, 7:44.
Yep. We're getting up there.
Oh. Stop advertising to me, Dropbox. Okay. Okay. Awesome. All right. Let's look at people's questions.
Okay.
Hal McKinney asks, would star systems orbiting closer to our galactic supermassive black hole center have a more difficult time holding on to its planets than star systems further away from the galactic center? So I kind of have an answer for this.
Go for it.
So the sun and the solar system is being pushed and pulled by all of the stars that are near us. And there is over the course of the next 10 billion years from now, especially as the sun's going to go into its red dwarf phase, and then it's going to go into its white dwarf phase. And it's going to end up with half of the mass that it had before. And it's been estimated that over the next 10 billion years, the solar system will lose all but one of its planets to gravitational interactions with the mass loss from the sun, and then gravitational interactions with other stars. And that within 100 billion years, the sun will lose its final planet and the sun will be solo. But there is a 1% chance that we will lose Mercury throughout the age of the sort of main sequence lifetime of the sun. So those kinds of gravitational interactions that are just happening to the solar system, we're halfway out from the center of the Milky Way. You can imagine as you get closer and closer to the center of the galaxy, those kinds of gravitational interactions are happening. The stars are way more dense at the middle of the galaxy, and they're going to be interacting. And also you do have those interactions with the supermassive black hole. And so it would, I'm talking out of my butt here in that I haven't read a specific paper, but I'm assuming that more stars, more problems. And so stars would have a much harder time holding on to planets as you get closer to the center of the galaxy. And not necessarily because of the black hole, but just because there's so many stars there.
And so the key here is, and the same thing applies in globular clusters, that the more often two stars pass near each other, it's the gravity from this interaction that is going to send stars off into the galaxy as free roaming objects.
Yep.
Being near the supermassive black hole, if you started out there, would have changed where planets can form, and wherever they formed is a healthy enough place for them to be if you stay in place. Now, the issue is that there's various dynamical reasons that objects can move inwards through the galaxy. So as something gets closer and closer to the sun, as something gets closer and closer to the supermassive black hole, you do have to worry about the balance of power, so to say, between the gravity of the star and the gravity of the supermassive black hole will cause solar systems to yeet their worlds into their own orbits around the supermassive black hole.
I mean, we see these hypervelocity stars that are moving through the Milky Way. They're going hundreds of kilometers per second. They're on escape trajectories. And it's believed that these stars were once part of binary star systems that got too close to the supermassive black hole. It plucked one away and said, this is for me. And then the other one was able to keep going. but now no longer has,
It's a
got a
three-body
slingshot.
interaction.
Yeah, got the slingshot, and so now it's busting it out of here. And so you can
Yeah.
imagine the same thing, that you get too close to the supermassive black hole, and the black hole goes, yeah, I'm gonna jiggle those planets around for a little bit. Maybe I'll keep them, maybe I'll just throw them out of the Milky Way. Who can say? But I'm the one with the power here. So yeah, yeah, absolutely. Hal McKinney asks a second question: would we feel heavier if the Earth slowed down from spinning at 1,000 miles per hour? Yes. But wouldn't I mean, would we feel it?
Yeah, that's where I don't think we'd feel
Yeah.
it.
No,
No.
it's like less. I forget what it is. You lose like a less than a pound.
So there was a
We get the
really
exact
cool
number.
research study I found. Let me see if I still have it open so I can tell you who wrote it. On how astronauts perceive time. And they don't perceive it quite the same way. But it's for a combination of reasons that includes things like, okay, so it's a paper in NPJ Microgravity, is the journal. The title is Time Perception and Astronauts on Board the International Space Station. Lead author is Deborah Navarro Morales. And they tested 10 astronauts before, during, and after a 6 to 8 month space flight. And the things that they looked at were how accurately could they identify it's been a minute now? How accurately could they say how many hours it's been since they had lunch? How many hours they've been working on something? And reading from the abstract, compared to pre-flight estimates, there's a relative overestimation for the 1 minute interval during the flight and a relative underestimation of intervals of hours in duration. However, the astronauts accurately estimated the number of days since something had occurred. They explain, continuing to read from the abstract, prolonged isolation in confined areas, stress related to workload, and high performance expectations are potential factors contributing to altered time perception of daily events.
Yeah.
And I love the idea that it is not the lack of a definitive day-night cycle. It is the work pressures we're putting on astronauts that most deeply affects their ability to understand time. And I now want to repeat this study with like Amazon warehouse workers and just people in a bunch of different kinds of work environments that are very regimented, because you have to have a regimented schedule in order to be able to do replicatable research.
Oh, that's really interesting.
And yeah.
So I ran the calculations here back to the previous question, that if you were standing on the equator and you weigh 100 kilograms, then you would experience a 0.346% decrease in your weight. And so you would weigh, so if you stepped on a scale that was 100 kilograms and then the Earth stopped turning, you stepped on the scale, you'd now weigh 99.65 kilograms. So it's very small difference. You're not going to notice it.
Yeah.
But it is measurable.
Yeah.
And in fact, people have done this experiment. You can go to the North Pole, you can weigh yourself on a scale, and then you can go to the equator and you can weigh yourself on the scale. Or you can take a mass and weigh it, right? Like yourself,
Yeah, they do it with test masses.
You do it with a test mass, and yeah, the test mass changes weight because you're at the equator. Explain that, flat earthers. Yeah, you weigh less.
What?
Because you are being spun on the Earth. The Earth is trying to throw you off into space, and so you are going to, you don't weigh in kilograms. You're going to. You experience a lower force when you are at the equator because you're trying to be thrown off the Earth. You don't weigh in kilograms. You don't? When I step on my scale and I set my scale to kilograms, does it not tell me a number in kilograms? Is that not my weight?
That is your mass. So
I know. So So why? So then why isn't my scale telling me
Your
my mass
Newton.
in newtons? Yeah,
This is
my
one
weight
of
in
those
newtons.
great things that every physics professor laments.
Yeah,
Yeah,
because because they are interchangeable from a casual perspective.
yeah, yeah,
That your mass is your weight when you're on the surface of the Earth, and it doesn't really matter.
yeah.
There's no difference. It's only when you have to think about your mass in other places that it does matter. There's no more questions, so I guess somebody wants a rant. Do we have a rant?
So there was a fascinating thing that I
I do
didn't
have a
spot
question
it.
for you, but
Someone
yeah, go
else
ahead.
spotted and pointed out to me down at the Titusville Kennedy Space Force Cape Canaveral area. There is a giant Amazon warehouse on the property of the Merritt Island. And it's not like a shipping warehouse. It's where they have their Kepler missions getting put together. So it
Oh,
just looks like an Amazon warehouse, but it's the Amazon Kepler building, and it is separate from the Blue Origin campus that is painted like blue. And
yeah.
in related chaos of where Pamela's brain went, I went Blue Origin, Blue Moon, Blue Ghost. I don't know why they're all named blue, but I assumed it was for a similar
Planet
reason.
Earth, planet Earth. That's what Blue Origin comes from, right?
Right, but then why do they have their Blue Moon landers? That's where my
Well,
can.
because everything's coming from Blue Earth,
Right, but
Blue Origin. Earth started at the blue, and so you're just gonna adapt it
so
across the
so
naming.
then I was trying to figure out why Firefly Aerospace followed the blue trend because they're their own company. And it turns out Blue Ghost is a kind of firefly. So it feels like it follows the pattern, but
Oh,
it's actually a kind of firefly.
that's really cool. I had no
Yeah,
idea that that was
I
the
didn't
reason that they
either.
came up with that name. Oh, that's really
So
cool.
I learned that today. It brought me joy. And
Okay.
yes.
So there's something that you have some experience with, and I'd be interested to hear this explained. So
Okay.
from what I understand, with the recent budget cuts in the US, your in the olden days, when you were putting in a proposal for, say, the National Science Foundation,
Yeah.
then you would set aside some amount for indirect
Overheads.
expenses,
Yeah.
overhead. And that number would be somewhere in the kind of 30 to 50%
Yeah.
range. And recently, now the new regulation
National
is that
Institutes of Health are
it's
capping
locked
it
at
at 15.
15%. Yeah,
Right.
15%. And so give me a sense, like when you're like what are the implications of that? Like if you're writing a paper, do you account for those indirect expenses in your, in the grants that you're requesting?
Yeah, so this is something my institute's been discussing on our list serve. So overhead costs are set in agreement with one of different government agencies. I think ours is through Health and Human Services, but I might have that wrong. There's different government agencies will do a complete audit of multiple years of a businesses and institutes and university spending to come up with what is the cost of doing business? What is the cost of your rent, of paying for the accountants, of paying for the audits, of paying for heating, cooling, repairing the roof, replacing the pipes that randomly got stolen off of our building over the weekend, apparently. I'm really glad I'm not working in Tucson.
Yeah.
And so all of these costs of doing business, rather than having to itemize them when you put in a proposal, get lumped in to the federally negotiated overhead rate. And it's based on actual costs, and it gets renegotiated every some number of years. I don't need to know, so I don't know,
Yeah.
to make sure that your company hasn't instituted cost-saving measures or to fix things if your company has gotten more expensive to run due to like energy costs going up.
And so sorry, so like if say, you are associated with the Planetary Science Institute, and so they are the umbrella that you will deliver, you'll write grants for, that you're going to be doing under their auspices. And so you will set aside, in addition to the direct funds, costs, you will set aside an indirect cost at you say 36%. And this is a number that the Planetary Science Institute has agreed, and this is sort of the nationally recognized number.
Based on audits.
Right.
And so for the Planetary Science Institute where I work, there is a fringe rate on salary that covers Social Security, insurance, all that sort of stuff that varies on what benefits you get. So it's 11% on my salary to cover the tax implications of having me as an employee, and Social Security and workman's comp and all those things that they have to pay because I exist as an employee. So my salary gets 11% fringe added on top. That should not be affected in any way. Then all the costs get an additional, because I don't work in the offices, get an additional 30% on top, which means I do not need to handle my own bookkeeping. There are people who handle the bookkeeping. I do not need to handle all of the federal reporting duties on our budgets. I do not need to fill out all of the paperwork. All of these things are being done by people whose entire salary comes from overhead. Right. And these are some of my favorite people.
Yeah, no, absolutely. I mean, like having administrative people, having bookkeepers, having accounting, having facilities, like all that, all of that kind of stuff. And as you say, that's done through auditing. And so I guess if somebody just waves a magic wand and says, actually, you only get 15%, what are the inevitable consequences of that?
So two things are going to end up happening. The first is, wow, I don't know what I just did, but I triggered balloons going off. I don't, okay.
In Zoom?
Yeah, Zoom suddenly triggered balloons flying across the screen. I don't know what I did. Anyways, reasons to figure out how to turn off reactions, I guess. You now have balloons going off.
Okay. So it was a reaction, yeah.
Yeah. So anyways, what you end up having to do is directly bill anything that can be considered an allowable cost. And we'd already seen this happening with businesses that hadn't existed long enough to have federally negotiated rates. If you don't have a federally negotiated rate, it gets capped, I think, at 10%. It might be capped at 15%. There is a cap on what you're allowed to ask if you don't have a federally negotiated rate that's in that range. And so what they'll do is they'll put in that amount, and that's to cover the building, the websites, all that sort of stuff that businesses have, and then directly bill the time necessary to do all of the reporting duties.
So theoretically, could you then turn what were once indirect expenses back into direct expenses? You're like, well, now we're forced to do our own bookkeeping. Now we're forced to build our own website. And now we're forced to
it drives up the costs. So now
but it goes into your direct expenses, and it becomes things that you have to now be responsible for.
And it drives up the amount of money you have to spend because you now have to allocate everything separately. So just the amount of time that it takes to have to, it's just like the difference between universal health care costs less than having myriad different insurance companies in the United States, because some poor sod has to sit there and say, this cost goes to this grant, this cost goes to this grant. So now at the institute I'm at, I have to, for every hour I spend doing stuff that is actually billable, and things like telecons and reading my email, I have to volunteer to do all those required tasks. It's super annoying.
Well, so do I.
Yeah, it's still super annoying.
Yes.
So anything I do that is a billable hour, I have to go into my timesheet and say, this gets billed to this account number, this gets billed to this account number. But the folks who are doing all of our accounting, they just do the accounting and they don't have to say, right now I'm working on a spreadsheet for this grant. Right now I'm working on a spreadsheet for this grant. Can you imagine how much time it's going to take for those humans to then have to allocate their time on a per grant level for an institute that has hundreds of grants?
And so what do you think are going to be the practical implications of this decision? I mean, is it going to is everybody just going to have to do a lot more administrative work to make their science?
It's going to depend on the size of the institution. For tiny places like I'm at, it can be handled because we have very few people doing a lot of heavy lifting. At universities, where you can't necessarily say this space that is used for 5 different programs can be divided up across these different ways, you're not going to be able to recoup through direct billing all of the costs.
Right. It's going to get very complicated.
And it's going to end up at universities driving up tuition, driving up fees. States are going to end up having to pay more money to keep institutions going, where the federal government was previously covering a lot of costs through the overheads for the different research laboratories.
Do you think it's going to drive more research to smaller institutions?
No, because a lot of smaller institutes won't have, so the smallest institutes won't have enough people to figure out how to do direct billing. The medium-sized institutes can't grow too much, or it becomes too burdensome to figure out how to do this. So there's like a sweet spot where you can direct bill and recoup your costs and survive. Once you get past that, you just can't do it, and it doesn't scale.
Yeah.
It's
And so are we going to see like less, like I'm trying to think some science, it will still make sense and people will be able to pull it off. But then there's going to be other, like I imagine, like say you're assigned, like working for the NIH and you're part of a research lab and your indirect costs go for paying for the mass spectrometer.
Yeah.
And so for the research lab to be able to continue to invest in the cutting edge tools and equipment, you need to be able to contribute
That's direct
to
billable.
the
That's
larger
easier. But how do you allocate getting a new roof for the building? Roofs have to be replaced now and then.
Right. Yeah. I mean, it's the exact same problem of like your condo strata, where you put in money into an emergency fund for the condo, and then that goes out to replace the roof or goes out to do whatever. And if you're just like, everyone goes like, no, we only get a third of as an investment, then over time these facilities wear down.
Crumble.
And if you don't maintain things, then the loss of function accelerates.
And so you have to get the money somewhere else. And this is where it's going to put a greater burden on foundations, a greater burden on
Private donations.
And so, for instance, at the institute that I'm at, our current rule, which may have to change, is you cannot apply for foundation funding that caps the allowable overheads unless you have some other means of paying those overheads, because that's how much money it costs our institute to do stuff, and they're not going to change that.
Yeah.
And so if someone wants to get money from the Templeton Foundation or the Moore Foundation or any of these other foundations that fund a lot of science, you have to say, okay, I need to have private donations that will cover however many $1,000 in overhead the foundations won't allow us to do.
Yeah.
And so that gets tricky. You can do it, but now you're increasing the amount of time you have to put into fundraising, which can't be paid. The amount of unpaid labor is utterly exhausting, and it's only going to go up because there's going to be fewer monies available for grants, more people competing for lower pots, and you have to get more and more because the money available covers less even if you do get it. And their ultimate goal is to get fewer people participating in science, to get fewer, to get,
I mean,
they're crashing the economy.
I mean, it sounds like an amazing opportunity to pick up American researchers.
Yeah, there's going to be a
In
massive
other
brain
nations.
drain.
Yeah, it's going to be a brain drain.
Drain. And what we are going through very much what was seen in the transition from the USSR to Russia, where they're looking to sell off federal buildings and drop leases, which are going to allow the oligarchs to scoop up massive amounts of real estate, which they'll then rent back to the government when it turns out that space, which we knew we needed, is, yes, actually needed. This is a repeat of what happened in the early 90s. We're going to see a massive brain drain as institutes crumble. Moscow University went from being one of the best institutes in the world with amazing facilities in the late 80s to someplace with literally crumbling infrastructure when I visited in, I think, 2015.
Yeah.
Yeah.
Well, we should go.
Sorry.
No. I mean, like, I know you're going to start spiraling. So
So for those of you who don't know, I was in the USSR. Up until 2 weeks before the coup. So I saw all of the shit happening.
Yeah.
And there's PTSD literally associated with this.
Yeah.
So,
yeah. Totally. Well, thank you everybody for hanging out with us today. Thanks, Pamela, for bringing the brain. And we will see all of you next week.
Yep. And I'm going to awkwardly fail to transition. One moment, please. I made the window too small. Now I have to make it bigger.